Welcome to the MixWorx Quick Start Guide. Chapter 1. What's in the box?
The sensor we are going to use today is the MixWorx. Okay, now let's take a look what's inside. Okay, inside of this case, you could find several items. The most important one is the sensor, MixWorx. Okay, so this is the 27mm cube, and this case is 3D printed. And inside of this sensor, there are accelerometer, gyroscope, and a thermometer. So you can just use the sensor to collect this acceleration, rotation, translation, temperature during the compaction of this asphalt mixer. And this is the data receiver, and here is the antenna. So before the experiment, you want to connect this antenna with the data receiver and use this cable to connect this receiver to your laptop. And we also give you another cable extender for some special cases. When this laptop and this data receiver is too long, you may need to use this. And lastly is the screwdriver. You may want to use it to open the sensor to replace battery if needed. Okay, so before the text, we just need to collect the data receiver with your laptop.
Chapter 2. Initial setup and connection. On this page, you can search, identify, and connect to the MixWorx sensor. The first step is to locate the sensor. If the correct sensor ID does not appear, click Open Port in the top right corner, then select Scan in the bottom right corner. In some cases, you may also need to click Refresh List to display the correct MixWorx ID. Select the MixWorx ID from the list. Then, click Connect to establish the connection with the sensor. This page checks the sensor's temperature and battery status. Click Next. Once both indicators turn green for best performance, keep the sensor temperature between 20 and 30 degrees Celsius to prevent overheating during compaction. This page monitors the sensor's signal level for a stable connection. The signal should be stronger than -70 dBm. If needed, move the sensor closer to the antenna to improve the signal. Once the signal indicator turns green, place the sensor on a flat surface and click Initialization. Keep the sensor static for at least 30 seconds while it collects initialization data. When initialization is complete, click Start Collection to begin recording MixWorx data. At this point, check the RX packet's value at the bottom of the page to ensure it is increasing steadily. This confirms that the data is being properly transmitted. If the RX packet's number stops increasing, the sensor may have disconnected. In that case, wait for it to refresh and reconnect. Chapter 3. Running the test.
Now we have moved to the compaction part. So we have all the sensor and the equipment set up. And this is the superfail generator compactor we're going to use today.
Step 1. Place half of the asphalt mixture into the mold. Step 2. Set the sensor flat on top of the mixture. Step 3. Quickly add the remaining half of the mixture to cover the sensor. Keep in mind, the MixWorx sensor is very sensitive to heat. Once it's inside the hot asphalt, you should start the compaction test as soon as possible. Do not let the sensor stay in the mixture for more than 10 minutes. And once the test is done, remove the sensor immediately to avoid overheating. On the Test in Progress page, you can click Show 3D Cuboid to view the sensor's rotation and movement. If you notice drifting or unexpected motion, just click Calibration once to reset it. At this point, you are ready to start the gyratory compaction test. You should see the 3D cuboid gently rotate in sync with the gyrations, and the RX packets value at the bottom of the screen steadily increasing. A typical successful test will show more than 7,000 to 10,000 RX packets, depending on the number of gyrations. You may also monitor the temperature to check for overheating. When the compaction test is complete, click Next and confirm. While the sensor is connected, signal strength may fluctuate depending on the environment. The software continuously monitors the signal until it stabilizes. After the initialization is complete and the sensor's signal strength has been verified, click Start Collection. When the icon turns solid, this will begin recording motion data. Until this point, make sure the sensor is kept at room temperature. Now, while data collection is running, prepare the gyratory compaction mold.
Okay, for this asphalt mixer, we use the gyratory control, and we use the 125 number of gyration. That is because we want to just collect as many data as we want, so it includes the initial number of gyration, design number of gyration, and maximum number of gyration to include the whole compaction process.
To stop data collection, immediately extrude the specimen from the mold. Use a spatula to break open the specimen, remove the sensor, and use a fan to cool it back to room temperature. One last caution. Do not start another compaction test until the sensor has fully cooled back to room temperature. Chapter 4. Processing the data. Before starting data processing, locate the file to be processed on your computer. By default, data is saved in the Data Logs folder. Do not process the raw data. Instead, open the MixWorx folder where files are organized by the time signature of each experiment. Each compaction test generates 5 output files: acceleration, battery, pressure, quaternion, and thermometer. The quaternion file is the one to be analyzed. You can also confirm it by checking the file size. Quaternion is usually the largest file for each test. To begin the data analysis, click the MixWorx icon to open the software's main page. If the program does not open properly, right-click the MixWorx icon and choose Run as Administrator. Next, select Analyze Previous Tests. Click Import Data and locate the quaternion file you want to analyze. To proceed, you have 2 options. Choose Select Data to define an effective segment for gyratory compaction analysis, or choose the Direct Use tab if the full dataset can be analyzed without reselection. To select an effective data segment, pick an element that shows a clear sine wave trend. Typically, element 1 works well. Define the start and end points of the sine wave segment, either by manually entering the values or double-clicking directly on the curve at the desired start and end points, then following the prompt. For easier selection, you can zoom into the starting and ending sections of the data. Click Selected to view only the chosen data segment, or Restore to return to the full dataset and reselect. When you are satisfied with your selection, click Next to continue. Now, click Calculate to automatically run a series of computations, including to trend quaternion, calculate Euler angle, and calculate relative rotation results. If needed, select Change All to adjust the sampling frequency or to manually enter custom initialization values. For the 4 elements used in the global coordinates transformation, All calculated results are displayed in the Rotation Visualization panel on the right side of the page. You can select and plot rock quaternion, Euler angle, or relative rotation along the X, Y, or Z directions. You may also choose to view the average relative rotation plot for the X and Y directions to determine the Workability Index Relative Rotation Capacity RRC, enter and initial and end design gyration numbers. Click Calculate Next to the relative rotation capacity. Finally, use the panel on the right to export data or generate report documents. The relative rotation file is usually the most relevant. It allows you to view relative rotation along the X, Y, and Z directions. Calculate the average for the X and Y directions and generate the corresponding plots. To generate a report, click Document Generation. Enter the key project and mix information, then click OK when prompted. A Word document will be created containing the essential mix design information, relative rotation plots, and the summary relative rotation capacity RRC value. You may further edit this document to add more project or experimental details as needed. Save the modified report document to the appropriate directory. To begin a new testing experiment, click the Next Experiment at the top right of the panel. When prompted, rescan and reconnect the device. For questions regarding MixWorx, contact us at sales@instrotech.com or give us a call at 919-875-8371.